Integration is the reverse of derivatives, right? So antiderivative, that's process. So derivative had lots of rules. So substitution rule is reverse of what derivative rule? Anybody remember? Chain rule, that's right. Reverse of a chain rule. Let me write that down here. Substitution rule that we've been using, substitution rule is really reverse of chain rule. Okay? You make a u substitution and then differentiate it with respect to u first and multiply du dx. That was a chain rule, right? So let me remind you of the chain rule. If you're doing dy dx, for some reason, when you look at this y expression, if you look at it in terms of u, it's a lot simpler. So think about u differentiated with respect to y differentiated with respect to u, then you multiply u differentiated with respect to x. That's the chain rule. And reversing that was the substitution rule we've been doing. So integration by parts is, this integration by parts is reverse of product rule. Okay? So I'm going to write down the product rule and see how we can reverse that one. Let's see. This is the product rule. EDX. Let's see if we have, most book uses u and v. You're looking at u and v as a function of x. So when you differentiate it, how do you do it? First differentiate u first and v later, like this, right? Is that correct? So they decided to isolate one of the thing like this and solve for the other. So u prime v is equal to d dx, derivative of uv, minus uv prime. Is that right? That looks like a formula. Okay? Then decided to put integral operator. So let's do that. Put integral operator here, uv, u prime v, dx. If you integrate this one, what's going to happen is that what happened if I put integral differential operator, then immediately followed by integral operator, integration operator. What happened to that two operators? They cancel. Differentiated and anti-differentiated. Then of course nothing happens, right? So you believe that this will be just uv this time? Right? Differentiated, then hit by integral. Then it's going to be, so let me write it down like this. And we're hitting everywhere by the integral symbol. We hit that with the integral symbol. We hit that with the integral symbol. That's what I'm doing right now. Okay? So let me move down a little bit. Then there will be negative, and then this will remain like this, dx. So we arrive this formula. So let me explain why this is called integration by parts. When you're looking at inside the integral, product of two functions, right? So I'm going to describe it like this. We're looking at integral with as a product of two functions here. And first thing you do is that, so think about what happened. This is a first factor and that's a second factor. Okay? Second factor appeared exactly the same here, right? But the first factor did not appear exactly the same. What would be the word that described the relationship or operation going from here to there? U prime became U. Isn't that integration? Right? Just that first factor u prime is integrated and appear in the first term. But the second factor, nothing happened to the second factor. That's how this first term appeared. Now you wrote it down, u and v, and you compare from here to the next part. Nothing happened to u here and u there, right? The integrated part appeared exactly the same, but the second factor that was just copied it from earlier step now is differentiated. One factor integrated, next factor differentiated. This procedure is called integration by parts. Let me say that again. First, you integrate one factor. Next, you differentiate the other factor. That's one way to learn this one. So let's see how this one plays in actual examples. So here's an example, and let me explain that principle one more time. All right, first you recognize this integrand is a product of two functions, right? We have two choices, and which one are we going to integrate first? Okay, if the first, let me just do that for fun. Well, first factor here, I decided to integrate that. Is it easy to integrate that just factor alone, x? So I'm going to do that. So here's a 2. Solution number 1 is that I'm looking at x times e to the x dx. So I decided to integrate that part. Okay, so integral 1/2 x squared, is that right? That's the antiderivative of x. And what happened to the second factor? Nothing happens to the second factor. You just write it down, copy it down like this. Okay? And there is this negative symbol always, because the product rule is organized in a different way. And there's this integral symbol. Okay? Then remember, this part was just integrated from earlier one, right? So that nothing happens to that. You just copy it down like that. And this part, nothing happened to that. What happened to this second factor this time? Differentiated. One factor is integrated, the other factor is differentiated. Okay? So we differentiate that one. So it's e to the x is written here in dx. So I'm going to write down this one is anti-differentiation, antiderivative, and this one is a derivative. Make sense? Antiderivative and derivative, that's the procedure. Whatever this is a correct statement. It just got harder here, right? If this gets easier, maybe that's why we do this, correct? If this guy gets harder, why would you do that? So let me go back and failed and decided to integrate antiderivative the other factor, right? Doesn't matter how it's ordered. You decided to integrate which factor, just remember that part. So before I integrate that one, right? This time I'm going to integrate the other one. So what is the integral of e to the x? E to the x, and nothing happens to x. See that part? Make sense? So that part here is antiderivative. Good? And nothing happens to x. So there is integral. The first term does not have an integral. How about what happened here? Nothing happens to e to the x, right? That was just, we did something about that factor, so we just copied it down here. And what happened to that x? That was the part that's untouched in the first procedure. So this time we differentiate x, right? One factor is antiderivative and the other factor is differentiated. So that one goes there as a derivative. What's the derivative of that? 1. Then you realize, hey, they got a lot better. This guy is a lot better, right? Antiderivative e to the x. X times e to the x, and what is it? E to the x plus c. So we got rid of the integral. Because the second term of the integration by parts got easier, then you could do that. Sometimes it's to look better than that, but it's still hard, and then you have to keep repeating it. And this procedure of applying this integration by parts and fold it inside and again, sometimes give you a surprising result. And that's one of the things that what I mean by the integration by parts is so important in mathematics. Okay, so if you don't believe the answer, you go and differentiate this one and simplify, and you really get this one back. That's how you check your answer, right? Find an antiderivative. Let's look at next example. Let's practice together one more time. Let's think about which one to integrate and which one to differentiate. You know, when you integrate and differentiate, and sine and cosine will just keep going back and forth, right? But when you differentiate x, we saw that it disappears, right? And that's good. So we'll differentiate x. That's the idea. All right. Let's do that. Just think about the first term where there's no integral. Which one are we integrating first? Sine or x? Which part? We're doing sine, right? So what is the integral of sine? I think it's negative cosine, right? And then it's positive sine. Negative cosine is integral of sine. And there is this default negative there, right? And you compare that term with what's inside the integral. Hey, x was just copied down here, right? This time, that guy is going to be differentiated, 1. And you have to copy right before this term in the middle term there. So it's negative cosine x should be copied down like that. Okay? So does this integral part better? There's something you can integrate, right? So here's negative x times the cosine x plus cosine x dx. That's integration by part. So what is it? I think this is just sine x, right? Plus c. Antiderivative of cosine x is sine x. Just plus c. Interesting, right?